Alright, so today we're going to learn how to solve the last type of projectile motion problems. So these are a projectile that is launched at an angle from unlevel ground. So we're kind of combining types 1 and 2 together. It's not symmetrical, right? So it's going to look kind of, if you're on a cliff or some type, right? So it's going at an angle up and then coming back down. So we can't use time divided by 2 to find the max height. We can't use that final is equal to initial. There's no symmetry, so there's really no shortcuts here. So it just means we've got a little bit more work to do. Right, so what we do know, though, is that at our max height, our vertical velocity is 0. So we've got our dy here. So the height that we start from, we know time is 0 here. Time is 0 when it hits the ground. Not time is 0. Height is 0 when it hits the ground. Gx is where it's launched from. Again, VIY is not equal to VFY. So we'll have to do a little extra work on this one. Okay, so our variables are still our range, horizontal velocity, and time. Here we have vertical displacement, initial vertical, final vertical. Acceleration still negative 9.8, and again, time is still the same for both parts. All right, so let's get started here. Right, so we can use our initial height to find time. Yes, we're going to have to use a quadratic formula. Our max height occurs when our velocity, final velocity is 0. And Pythagorean theorem and tangent to find the final velocity, just like we did with type 1. So, a golfer strikes a golf ball from the top of a 2.3 meter tall hill to the green below. So we're up 2.3 meters. Golf club, that's a really bad golf club. It's okay. Trying our best here in a golf ball, right? So he hits it at a 45-degree angle. So then the ball is going to do this and fall down below. Okay, the initial velocity is 28 meters per second. Determine the golf ball's time of flight, range, max height, and final velocity. Okay, so we're going to do our little shrinky shrink here. So the first thing we need to do, after we make our columns, that is, we need to find our velocity components, right? Okay, so remember to find horizontal, we use cosine. So that one's going to be 28 cosine 45. And then vertical will be 28 sine 45. Okay, so we can do that math, and you get 19.8 meters per second for Vx and 19.8 meters per second for VIY. Because remember, sine and cosine at 45 are the same thing, so it makes sense to get the same velocities here. Okay, so then let's fill in everything else we know. So we have to find dx and t, which we don't know yet. Dy, vf, a, and t. Okay, a is always negative 9.8. Right now we know dy is negative 2.3 meters, right? Because that's what we're starting at. We don't know VFY and we don't know time. So let's go ahead and start by calculating time using what we know here. Okay, so we'll use our favorite equation. I don't know that it's actually our favorite, but it is the most commonly used for these projectile motion problems. Okay, so dy is negative 2.3. VI is 19.8 t plus 1/2 times negative 9.8 times t squared. So negative 2.3 Okay, so remember we need to set it equal to 0. So I'm going to do that in root. So basically I'm adding the 2.3 over to my right side here. So then you get 0 equals negative 4.9 t squared plus 19.8 t minus 2.3. Okay, so remember, plugging into our Pythagorean theorem, we have A, B, and C. So we have negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So plugging in, we have negative 19.8 plus or minus the square root of 19.8 squared minus 4 times negative 4.9 times negative 2.3. Sorry, positive. That's a positive 2.3 because we moved it over. That would have messed us up, but we caught it in time. All of that divided by 2 times negative 4.9. Okay, so we are going to work this out. And we get t equals negative 0.113 and 4.15. So obviously we can't use a negative time, so the ball hits the ground after 4.15 seconds. So now that we know time is 4.15 seconds, let's write that in. Okay, so we found time of flight. So now we've got to find range, or dx. So v equals d over t. So 19.8 equals d over 4.15. So multiply on both sides. And that gives us dx is 82.17 meters. Okay, so we're going to shrinky dink that. I'll leave it over there. Okay, here we go. Just trying to keep everything together and give myself room. Okay, so now we need to find our max height. So remember we said our velocity, what we're considering our final velocity, meaning the velocity at the max height would be 0. So we can use the equation VF squared equals VI squared plus 2AD, right? And we'll use that to solve for D in this case, right? Because we know that at the max height, our final velocity is 0. Our initial is still our 19.8. 2, we know acceleration is negative 9.8, and D, 19.8 squared. Okay, so we will square the 19.8. Which gives us 392.04. And 2 times negative 9.8 is negative 4.9 times D. So we'll subtract this over. And then divide by negative 4.9. Nope, I am so used to multiplying by a half. It is not 4.9. I'm sure you guys were probably realizing that well before I did. Oh, it's still 2 times 9.8. Negative 9.8, which is negative 19.6. So that is negative 19.6. I was wondering why my number was so far off. So then we're going to do 392.04 divided by 19.6, which gives us 20. So our max height is 20 from where we started. Right, so we're 20 above our start height. So that means to find max height, we have to add 20 to the 2.3 we were already off the ground before we started. So our max height is 22.3 meters off the ground. Okay, and then finally we need to find our final velocity. So we can use our same equation we just did. Let's get a new color. It's almost Halloween. Let's go orange. Okay, so we're solving for VF squared. VI is still 19.8. And we're going to use our negative 2.3 here. Right, we don't want to use the max height. Because we know, right, if we use the max height, we'll get back to where we started and get a final velocity of 0. So 2 times negative 9.8 times 2.3 is 45.08. Oh, 19. I keep forgetting that squared, y'all. So that is, so 437.12 is VF squared. So to get our final answer, we take the square root, which is 20.9 meters per second. right? And it's technically negative because it's going downward. Okay, and then our last step, I'm going to go to the next slide for this one. Right, we're going to use our Pythagorean theorem. So 19.8 squared plus 20.9 squared gives us 828.85. So then our final velocity is 28.79 meters per second. All right, hopefully y'all followed along with me, and you're good to go. You've got one more practice problem to do. Tomorrow we're just going to do, I'm going to leave a couple extra practice problems for those of you that are there. Those of you that are participating in the volleyball tournament, good luck. Wish I could be there, but unfortunately I can't. So best of luck to you all tomorrow, and let me know if you all have questions.